Hello, so this recording is to help with the summer task for computer science at St. Brendan's College. I'm going to be looking at the pseudocode on page 5 of the summer task, which is shown here, and it consists of pseudocode and a trace table. First of all, pseudocode is simply a code that, instead of being written in a particular language, is written in a form that is not specific to any one language and can be transformed into Java, C, VB, whatever. And it uses more English-like instructions, and it can be translated into or out of languages. A trace table is used to help to work out what pseudocode does, and usually consists of having columns that have a value which can be changed by the pseudocode. These are usually variables, and often a column for whatever is output, displayed, printed, whatever that may be. This is a relatively simple piece of pseudocode, but let's look through it because a lot of the things that happen here will happen in more general, more complicated cases. So let's look through the pseudocode. We will be looking through each line of pseudocode, and then as we work our way through, we'll be putting the effect onto the trace table. If there were more than one variable, the variable here is A, we would have more columns in the trace table so that we could work out what is happening to each of those variables. The variables are actually held in memory, so you can think of a variable as being a location in memory that is having its value changed. It can only hold one value at a time, and so if a value changes from 4 to 5, we can record that it was 4 and becomes 5, but in the actual memory location, the 4 will have been lost. So it can only keep the latest value. But a trace table will tell us what the value was as well as is, whereas in memory, it will only record what that value is, not what it was. Okay, so let's make a start. So the first line of pseudocode is input A, and in this case we're this trace table here, the first one, we have an input value of 5, so we record the A as being 5. The next line uses the mod function, which essentially gives you the remainder when you do division. So here it says if A mod 2 is 1, now A is 5. 5 mod 2 means the remainder you get when you divide 5 by 2. 5 divided by 2 is 2, with 1 as a remainder. So in this case, when we have A mod 2, A divided by 2, the remainder is 1. So the result of this check, this condition, is that the condition is true, and using an if statement, that's always followed by a condition, and if the condition is true, we execute the code that follows immediately after the if. If the condition is false, we execute the code immediately after the else, if an else exists. So in this case, when A is 5, 5 mod 2 is 1, so the condition is true, and therefore we execute the output A. Because A is 5, we output a 5, and the else part is not executed because the condition was false. And that's it. So a very simple trace table for the input value 5. And here it should be the input value 8. Error in the question, sorry about that. So for the input value 8, we now go to the same. Input A is 8, and A mod 2 is 1, so 8 divided by 2 is 4, remainder 0. So A mod 2 is 1 actually is not true, that's false. So the code that immediately follows the if, the output A, is not executed. Instead we go to the else and we output A minus 1. A being 8 means that we output 8 minus 1, which is 7. As simple as that. So we have a trace table here for the input value of 5, another trace table here for the input value of 8, and in the case of the input value of 5, we output a 5. In the case of an input value of 8, we output a 7. And so it's hopefully clear to understand that if we input other values, for example, any odd number mod 2 will give us a result of 1, and so we just simply output the odd number. However, if we input an even number divided by 2, the remainder will be 0, not 1, and therefore we'll execute not that line of code, but this line of code. So in the case of an even number, we will output the odd number, which is 1 less than that even number. And that's the purpose of this pseudocode. So by looking at two values, hopefully we'll be able to trace the output correctly of the different input values, but also it helps us to understand what the code does as a whole. So this pseudocode merely leaves an input value which is odd unchanged and changes any even value that's input to being 1 less, in other words, an odd value. So it always outputs an odd value. I hope that was helpful for you to understand the basics of pseudocode with this simple example. Thank you.